Hello, ladies and gentlemen. This video is a quick video to review our factoring skills and why we need it. That's a really good question. Why would we ever need to remember how to factor? Well, so far in this polynomial unit, we have learned how to add them, how to subtract polynomials, how to multiply them, how to divide them, but now we're moving into solving them. And so far, we've only solved equations that are linear or have just an x equal to some number, so we solve something by doing reverse PEMDAS. And we've also, in the last unit, we solved things with an x squared. But now what we're going to be doing is solving polynomials, which means things that have something higher than an x squared or an x term. So our goal is to actually solve big equations like this with really large exponents. And not only are we going to solve them, but we are also going to graph them in this unit. So for both solving and graphing these polynomial functions, we're going to need to remember how to factor. That's why we need to know all of this stuff. So our future learning goal, as I said before, was to find all the solutions. And now, before in our last unit, when we learned factoring, we broke it down by we factored by GCF, we factored by trinomial patterns, we factored by the difference of squares, or we factored by grouping. Now, as you can see in this example, you may have to use more than one of those methods to simply solve it because we started with a cubed as our degree, or a degree 3, which means we have to factor it once, and so that first time was by grouping, and then we still have to get rid of this squared, so we have to factor it twice. So when we find all the solutions, our goal is to get 3 solutions because we know our degree tells us how many solutions we have. That means we have to have that many sets of parentheses for our solution. So if our degree of our polynomial in this example was 3, that means that I have 3 solutions, which means that I'm going to have to factor twice so I can get my 3 sets of parentheses. And if we do something even higher than a degree 3, that means we're going to have to factor that much more. So you're not just going to factor once and be done like we've been doing in the previous unit. Now you're going to have to keep asking yourself when you're done and if you found all the solutions. But that's where we're going. All right, so the first form of factoring that we learned was factoring by using the GCF. And so for this first example, on your little half sheet of notes under the GCF box, write down the example 24x cubed minus 12x. So when we factor using a GCF, our goal is to find the greatest common factor of both terms. So look at the factors for the number and the factors for the variable. So 24 and 12 both have a 12 in common as a GCF. And then an x cubed and an x share an x in common. And so that's the GCF, but we want to factor using that. So that means that we're going to divide out or take out side of this parentheses a 12x from both terms. So 24 divided by 12 is 2, x cubed divided by x is x squared, minus a 12x divided by 12x is 1. So that's my final answer. So moving right along, we should have gotten 12x times x squared minus 1 for the first one. And now if we go over to the trinomial patterns, we have the example, which you should write down, 3x squared plus 11x minus 4. So remember, trinomial patterns was when we set up our 2 sets of parentheses, and then we asked ourselves, we thought about FOIL. So when we multiply these 2 sets of parentheses, what's it going to get me to my original equation? So we asked ourselves, what times what gets me to a 3x squared? That's my first times my first. So we know it's 3x and a 1x, because those two numbers multiplied times each other gets back to a 3x squared. Then we have to ask ourselves, what two numbers multiply to 4, but also add to 11x. So my last two terms in both sets of parentheses is going to be something times something to get to a negative 4. And at the same time, those inner and outer numbers have to add to an 11x. So if we put a 1 here and a 4 here, because numbers that multiply to 4 are 4 and 1, and it's also 2 and 2, but I'm going to try 4 and 1, and if that doesn't work, we'll go on to 2 and 2. So if we double check our work, which I'll do in gray, 3x times 4 is 12x, and then 1 times x is a 1x. And we want those two numbers to add or subtract to 11. So if I subtract the 1x, I get an 11x, which means that I would want the 1 to be negative and the 4 to be positive. So that's what we're trying to do. We have to think to the FOIL method to remember first times first, last times last, and then outer plus inner gets me that 11x on the inside. So my final answer is what's in parentheses. So I'll circle that in red. My final answer is 3x minus 1 times 1x plus 4. Okay, so for number 1, we should have gotten that answer. We should have gotten that answer for number 2. And now moving down to the difference of squares box, we have the example 25x squared minus 49. So for this example, remember for difference of squares, we have to first see that we have two terms. We have 25x squared and a negative 49. So those two terms have to be perfect squares. Well, 25 is a perfect square and 49 is a perfect square, and those two terms have to be subtracted from each other, which is what we have. We have that difference or that subtraction sign. So difference of squares is when we set up two sets of parentheses and we take the square root of 25x squared is 5x and 5x, and then the square root of 49 is my last term in both sets of parentheses, so square root of 49 is 7. And now we have to have one of each sign, because what happens with this guy, if we were to double check our work, if we refoiled or re-multiplied these two expressions together, what would happen is we would have 5x times 5x to get me 25x squared. We'd have 5x times a negative 7, which is negative 35x. Then we have 7 times 5x, which is a positive 35x. And then we have 7 times a negative 7, which is a negative 49. And these middle terms cancel, which is how I come up with 25x squared minus 49. So when you think the backwards process of that, we have to think the first thing times the first thing has to be a perfect square, which it was. The last thing times the last thing has to be a perfect square, which it was. And then we switched, or we had one of each sign, so that difference, when we remultiply, it gets erased, where those two terms cancel each other out. So my final answer for this guy is what's in parentheses, 5x plus 7 and 5x minus 7. So far, these should be your 3 answers for GCF factoring, trinomial factoring, and difference of squared factoring. And now we have one more example with factoring by grouping. So factoring by grouping. For that, we have the example x cubed minus 5x squared plus 3x minus 15. So when we say by grouping, typically you just choose, because we have 4 terms, group 2 terms and 2 terms so that you can find a common GCF to take out. So for the most part, we group it with the first 2 terms. So we look at just the first 2 terms, x cubed minus 5x squared. What do they have in common? Well, they have an x squared in common. Well, let's divide that out of each term for just the first 2 terms. X cubed divided by x squared is an x, and then negative 5x squared divided by x squared is just a negative 5. Now we look at, I'm going to use a different color, I'll use light blue. The last 2 terms, that's what we're going to group together. So we have 3x minus 15. So from those 2 terms, what do they have in common? Well, they share a positive 3 as a factor. So divide a 3 out of 3x, leaving me with x. Divide a 3 out of negative 15, which is negative 5. And then what happens, and I'll write this in yellow, is what's inside my set of parentheses is another common factor. We have this expression where it's x squared times this parentheses plus 3 times this set of parentheses. So we really only have 2 terms, the x squared times something plus the 3 times something. So of those two terms, what they have in common is that x minus 5. So let's distribute that out or take it out. And then all we're left with is another set of parentheses that's going to be multiplied, which is x squared plus 3. So that's my final answer for factoring by grouping. So typically when we group, we just group the first two terms and then the last two terms, and then from there, it's very similar to the GCF method where we find the GCF. All right, so to recap, these are my answers. I know I showed a little more chicken scratch and scratch work on the problems as we went through them, but make sure that these are the answers that you have circled in your notes so you know what the answer was. Remember, the whole goal of factoring is the opposite of multiplying or FOILing. So when you're factoring, your goal is to have all those sets of parentheses almost looking unclean because we're usually so used to simplifying and multiplying that all out. But now we're doing the opposite process. So that means that our answers are going to be left with all these sets of parentheses, which we call factored form. So thank you all for taking such good notes and for listening to this video. Review factoring is what we will be doing before we go on to solving polynomials and graphing polynomials. But we're really going to freshen up our factoring skills so that the rest of this unit is just smooth sailing. So thanks again, everybody, and I'll see you soon.